Ever get this feeling like when it comes to space, what we see is just the tip of the iceberg? Like
Mm-hmm.
there's this whole other universe humming along out there, invisible to our eyes.
Yeah.
Well, buckle up, because today's deep dive is all about radio astronomy,
Okay.
the science that lets us tune into that hidden universe. Get ready for interstellar molecules, whispers from the Big Bang,
Wow.
and even a little sci-fi tie-in, because why not?
And what's really mind-blowing is that radio astronomy isn't just for scientists with billion-dollar telescopes. Even you, from your own backyard, can pick up signals that have traveled billions of years across the cosmos.
Okay, stop, rewind. Backyard astronomy.
Yeah.
I'm intrigued, but first let's make sure everyone's on the same page.
Hmm.
We're talking about studying space, but instead of using telescopes that capture light, we're using radio waves, right?
Yeah.
Unlike the stuff we use for music and communication.
Exactly. But instead of picking up Beyoncé's latest hit, we're talking about capturing cosmic radio waves. These waves are incredible because they can cut right through Earth's atmosphere, which means cloudy weather, even daylight won't interfere.
Wow.
That's a major win compared to traditional telescopes, which need perfectly clear, dark skies.
So no more waiting for a clear night, just tune in anytime.
Exactly.
But if radio waves are invisible, how do we even see anything?
That's where it gets really cool.
Okay.
Radio telescopes collect these faint cosmic waves, and then supercomputers process that data into images, often color-coded to show things like temperature, density, or even movement. So we're not just hearing the universe, we're seeing it in a completely new light, or rather, radio wave.
Mind officially blown.
Mm.
But this all sounds incredibly complex. How long has radio astronomy even been around?
You might be surprised to learn that the field really took off in the 1930s, and get this.
Yeah.
The second radio telescope ever built wasn't in some fancy lab, but in someone's backyard. Grote Reber, an amateur astronomer, built a 31-foot dish right in his backyard and created the first ever radio maps of our galaxy. Talk about DIY.
Wait, seriously, backyard astronomy is a real thing, and it's been around for almost a century. That is wild.
Yep.
Okay, I need to hear more about what kind of mind-blowing discoveries we can thank radio astronomy for.
Hold on to your hats because the list is long. Radio astronomy helps us understand the sun's magnetic field, which is key for predicting those solar flares that can mess with our satellites.
Right.
It allows us to observe galaxies billions of light years away, pushing the boundaries of what we know about the universe. And here's a big one. It helps us track potentially dangerous asteroids.
Huh?
Talk about a cosmic early warning system.
Okay, that's pretty impressive. Mapping the universe, tracking asteroids. I'm starting to see why radio astronomy is so important. But let's get specific. What are some of those, you won't believe this, discoveries that have come from radio telescopes?
Oh, there are plenty. For starters, radio astronomy was crucial in accurately pinning down Mercury's orbit, which had astronomers puzzled for centuries.
Interesting.
It also gave us our first real images of asteroids, showing us these wanderers of our solar system in amazing detail.
I always pictured asteroids as these blurry blips, not something we could actually see.
That's the power of radio astronomy.
Fascinating.
It lets us see the universe in a whole new way, and it gets even weirder. How about binary pulsars? We're talking two super dense stars, remnants of supernovas, locked in a deadly orbital dance, spinning so fast they emit beams of radio waves like cosmic lighthouses.
Wow.
Then there are millisecond pulsars. These guys spin hundreds of times per second, emitting pulses with such precision they rival atomic clocks.
Binary pulsars, millisecond pulsars. This is definitely giving me some serious sci-fi vibes. And to think this is all real happening right now in the vastness of space.
And here's one more for you, ARP-220. This galaxy is like the cosmic train wreck you can't look away from. It's incredibly luminous and packed with gas, suggesting a history of dramatic collisions.
Wow.
By studying ARP-220's radio emissions, astronomers realized that these kinds of galactic mergers are way more common than we thought, reshaping our understanding of how galaxies, including our own Milky Way, evolve over billions of years.
ARP-220, galactic train wreck. I love it.
Mm.
So we've got these incredible objects emitting radio waves, but how do we even hear them from billions of light years away? This whole electromagnetic spectrum thing seems pretty crucial to grasp.
It absolutely is. Imagine a vast piano keyboard of light, way bigger than anything you've ever seen. Each key represents a different kind of light wave with different wavelengths and energy levels. Our eyes can only see a tiny sliver of this keyboard, the visible light spectrum, where we get all the colors of the rainbow. But the universe is playing music across the entire keyboard, from the low, deep bass notes of radio waves to the high-pitched, energetic notes of gamma rays.
Okay, I'm picturing this cosmic piano, and it's epic. So if visible light is like the middle octaves, where do radio waves fit in?
Radio waves are those super low, rumbling bass notes on the far left of our cosmic keyboard. They got the longest wavelengths and the lowest energy.
Okay.
Gamma rays, on the other hand, are like those high-pitched, almost silent notes on the far right. Super short wavelengths, incredibly high energy.
So it's like we've been listening to this tiny snippet of a song, and now radio astronomy is blowing open the whole orchestra.
Exactly. And what's fascinating is that each part of the electromagnetic spectrum tells a different story about the universe. Radio waves, in particular, are amazing because they can travel across vast cosmic distances relatively undisturbed. They're like messages in bottles, carrying information about the birth of stars, the death of black holes, even the faint afterglow of the Big Bang itself.
Now that is what I call tuning into the universe's greatest hits.
Yeah.
But we've been throwing around the term radio waves a lot. Can you break down exactly what frequencies and wavelengths radio astronomers are dealing with?
Think of it this way.
Okay.
Radio astronomers focus on a specific range of frequencies from about 3 kilohertz to 900 gigahertz. That might sound like gibberish, but essentially we're talking about waves that can be longer than a football field.
Wow.
And those frequencies translate to wavelengths ranging from hundreds of kilometers down to less than a millimeter.
So we're talking about capturing waves that are bigger than stadiums and tinier than a grain of sand, all to unlock the secrets of the universe.
It's pretty amazing, yeah.
That's pretty mind-blowing. But how do we actually do it? What kind of technology can pick up those faint whispers from billions of years ago?
Well, this is where we talk about the rock stars of radio astronomy,
Yeah.
the radio telescopes themselves.
Okay.
And just like the universe they observe, they come in all shapes and sizes.
All right, I'm picturing giant satellite dishes here. Are we on the right track?
You are definitely in the right ballpark. Those iconic parabolic dishes are a mainstay of radio astronomy. They work by focusing those incredibly faint radio waves onto a receiver, kind of like how a magnifying glass focuses sunlight.
Right.
But it's not just about size, it's about how you use it.
Okay.
For even greater sensitivity and resolution, radio astronomers use arrays, which are multiple dishes linked together,
Right.
sometimes spanning entire continents.
So it's like having one giant ear spread out across the globe, listening to the universe.
Yeah.
That's next-level teamwork.
Exactly. And these networks of telescopes are capable of some incredible feats.
Cool.
By combining data from dishes thousands of miles apart, astronomers can create images with a level of detail that would make your jaw drop. We're talking about seeing the supermassive black hole at the center of our galaxy, or mapping the distribution of dark matter across the universe.
Okay, now I'm really seeing the power of these arrays.
Yeah.
But hold on. We've got these radio waves, we've got these incredible telescopes. How do we go from signals to stunning images of the cosmos?
Right.
Is there like a cosmic Photoshop program involved here?
You bet there is. And it's not just one program, it's an army of supercomputers crunching numbers day and night.
Wow.
The amount of raw data collected by these radio telescopes is absolutely astronomical.
Literally.
Pun intended, yeah. These supercomputers have to account for Earth's rotation, the movement of the objects being observed, even tiny distortions in the atmosphere. It's like untangling trillions of cosmic threads to weave together a breathtaking tapestry of the universe.
It sounds like radio astronomy is as much about data analysis as it is about observation.
Absolutely. And the beauty of this digital age is that it's opened up the field of radio astronomy like never before. Now, with open source software and online databases, even amateur astronomers can access and analyze real astronomical data, potentially making groundbreaking discoveries from their own homes.
Speaking of amateur astronomy, earlier you hinted that even I could explore the universe with radio waves. Is that really possible? I don't exactly have a supercomputer or a giant satellite dish in my backyard.
You might be surprised how accessible radio astronomy has become. While professional observatories are still on a whole other level, there are now affordable, low-power radio telescopes designed specifically for beginners.
Wow. Okay.
And you don't even need a massive backyard. Some of these setups are compact enough to fit on a tabletop.
Okay, color me intrigued. So for our listeners who are now itching to try their hand at radio astronomy, what are some resources they can explore? Where do you even begin?
A great place to dip your toes in is online.
Okay.
Platforms like Coursera offer fantastic introductory courses like The Evolving Universe, which delves into the basics of astronomy, including radio astronomy.
And don't underestimate the power of YouTube. There are tons of channels dedicated to explaining complex concepts in an engaging and accessible way, with DIY tutorials and project ideas galore.
And for those who want to go deeper, the National Radio Astronomy Observatory, or NRAO, has a treasure trove of information on their website. From the latest discoveries to resources for educators and amateur astronomers alike. They even have guides on how to build your own radio telescope.
Building your own radio telescope. Now that's what I call next-level DIY. It's incredible to think that the same science used to map distant galaxies can be explored from your own backyard.
It's a testament to the fact that curiosity knows no bounds, and the universe is full of surprises waiting to be discovered, no matter your level of expertise.
You know, it's funny how we often think of astronomy as this visual pursuit, peering through telescopes at distant starlight. But radio astronomy really flips that on its head,
Yeah.
showing us that there's a whole other universe of information hidden in the whispers of radio waves.
It's like we've been reading a book with half the pages missing, and radio astronomy just handed us the rest of the story. Suddenly, we're not just observing, we're listening to the universe tell its story. From the Big Bang to black holes and everything in between.
And the best part is, you don't need to be a professional astronomer to get in on the action. It's amazing to think that anyone with a curiosity and a bit of know-how can explore the universe from their own backyard. Speaking of exploring the universe, it's time for us to beam down from the world of science and into the realm of pop culture because, let's face it, radio astronomy has inspired some pretty epic sci-fi moments.
Absolutely. And one film that immediately comes to mind is Contact, based on Carl Sagan's incredible novel. Remember that iconic scene where Jodie Foster's character, Ellie Arroway, puts on those headphones and hears the first faint whispers of an alien signal?
Oh yeah,
It's a moment that perfectly captures the thrill and suspense of searching for something truly extraordinary in the vastness of space.
right. Contact really gets across how radio astronomy is about more than just data. It's about pushing the boundaries of what we know and daring to ask those big existential questions. Are we alone? Is there anyone else out there?
And then you have a film like Arrival, which takes a completely different approach. Without giving too much away, it explores the complexities of communication and understanding when faced with an alien intelligence that perceives the universe in a fundamentally different way than we do. It's a film that really makes you think about the potential for radio astronomy to not only discover new life, but to challenge our very understanding of reality.
It's amazing how these movies, while fictional, tap into the very real sense of wonder and possibility that radio astronomy inspires. They remind us that the universe is full of mysteries, and sometimes the most profound discoveries come from listening, not just looking. So to wrap things up, I have
Yeah.
to say I'm completely blown away by radio astronomy. It's like we've just scratched the surface of what's out there waiting to be heard.
What's so captivating about radio astronomy is that it peels back layers of the universe that would otherwise remain hidden from our view.
Right.
It allows us to study the faintest whispers of the early universe, the birth cries of stars, the death throes of black holes. It's a field that's constantly evolving, with new discoveries rewriting our understanding of the cosmos year after year.
And who knows what incredible breakthroughs await us in the future. Maybe, just maybe, one of our listeners will be the one to make the next game-changing discovery, proving that the universe's greatest secrets are often just waiting to be heard. So keep looking up, keep listening, and never stop exploring the wonders of the cosmos, because the universe, as we're learning, is full of stories waiting to be told if only we know how to listen.